and see these examples. So as I told you, with every example, a new concept will be put in. So understand that concept well so that when the questions come, you can easily handle them. Okay. So ready, beta? Shall we move on to the questions?
Go ahead, sir.
Okay. All right, beta. Great. Okay. So this was the last question which we did in the last class. Now moving ahead, beta. Moving ahead.
Let's apply what we have learned to solve a few questions. In DR 17 degrees 41 minutes south, 179 degrees 50 minutes east, an intercept of 12.2 miles towards an azimuth of 081 degrees true was obtained by a stellar observation. Vessel then steered a course of 124 degrees true for 81 miles through a current setting 221 degrees true, drift 12 miles. When meridian altitude of the sun gave an observed latitude of 18 degrees 40 minutes south, find the position of the vessel at the time of second observation.
Okay, beta. So, beta, any doubt in the question? Give a reading to the question first. Any doubt coming in, let me know. Great.
Now, our first observation obviously is by intercept. So we need to get the position through which to draw the PL and also the direction of the PL. But to be able to see through the question, it's important that we make a rough diagram for this question and then figure out which part we have to calculate mathematically and then eventually perform the plotting part. Here we have the DR which comes up here, the time of first observation. Azimuth that time is 081, comes up on the screen. Intercept is towards, 12.2 miles towards, represented by blue line. This is the ITP, and here you have point X as the ITP, and you get the first PL. Now, vessel is somewhere on this PL passing through X at the time of morning or the first observation rather. Now, what do we do then? Now we have to apply the run and the current. We allow for current. So we take any point on the first PL, and obviously point X stands out by default, being the ITP. So we apply the ship's run from X. We apply this course of 124 degrees for 81 miles, and that gives us the point Y. Now all this plot is not to scale, it is rough plotting. At Y we apply the current 221 for 12 miles, and we get point Z. From chart work knowledge we know X to Z is our CMG and distance made good, CMG and DMG. Now we know that point X stands transferred to point Z. So point X, through which the first PL is drawn, is now transferred to point Z. That means if we can mathematically calculate point Z, provided we know the coordinates of point X. But we do not have the coordinates of point X. On the contrary, we have the coordinates of this DR. But we know the direction of X and the distance. So if you see, if I have to see from this DR and I have to come to point Z, then this is one leg that needs to be done. This is the second leg, and this is the third leg which has to be covered. So instead of, you see, there could be two ways of doing it. One is you calculate the coordinates of X, but that is again going to be time consuming. If we just put all these three legs together using the day's work concept, which we are all very familiar with, we can directly get the coordinates of point X. So this diagram is not to the scale, but let's see now if we work out the coordinates of X.
Beta, up to here, have you understood? Any doubts coming in?
Understood.
No, sir.
Very good, beta. Go ahead. Right. Right, beta. Right. Beta, if you find the position X using a diagram, you will have to make two plots. One plot will be to find the position X. Then another plot will be where Z is, where you will make both the PLs. So that is going to make it more complicated. And when you are going to use the calculation method for this course and distance, 81 miles and the current vector 12 miles, you will be using calculation method. Why not use calculation only from dr to x also? Right, beta? So whenever you have multiple distances involved in transferring a PL, it is always better to use the day's work principle and the calculation method, because graphically taking care of 2 or 3 or 4 legs will become little complicated. Okay.
Table we are all very familiar in the day's work. So in the remarks, we have the first would be this intercept leg. Why? Because why we are using this intercept thing here is, though this is before reaching the PL, but this is because we know the coordinates of the DR. So we have DR to ITP, the course will be 081 degrees, which is north 81 east, distance will be 12.2 miles. We'll have northerly DLAT, easterly departure, which you are all familiar with. Second leg would be the vessel steaming on a course of 124 degrees true, converted to quadrantal, distance 81 miles, and obtained the departure, DLAT and departure. And the last is the effect of current, 2 to 1 degrees, converted to quadrantal, 12 miles the drift, and we get DLAT and departure. Then we total up the DLAT and departure in each column, and we get total. And using the values in the two columns, we get the resultant of DLAT and departure. So we get resultant DLAT of 52.5 minutes south. This resultant DLAT is the DLAT from DR lat to latitude of point Z. And our point of interest is point Z. As long as I can get the coordinates of point Z, I'm not interested in the coordinates of point X.
Up to here, any doubts coming in, beta?
No doubt, sir.
Very good, beta. Great.
And departure from DR to Z is 71.3 minutes east. We know then what to do. DR lat is known to us, 17 degrees 41 minutes south. D lat we have just obtained to point X, and we apply, we get the latitude of point Z. So we have got the latitude of point Z. We obtain the mean lat between DR lat and Z. We convert the departure into D lat. Sorry, we convert the departure into D long, my mistake. And the D long comes to 1 degree 15 minutes east. We apply this D long to the DR long, and that shall give us the longitude of Z. And therefore, At the end of this working, we are able to obtain the coordinates of point Z. So that means when I go to the graph, I don't have to plot the DR, I don't have to plot this first PL, I don't have to plot this triangle. I can straight away come to point Z and transfer this first PL through point Z. So I'm sure this concept of day's work, which we're all conversant with, use of parallel and plain sailing concept, we're all conversant with. Looking at the rough diagram, if the rough diagram was not made, it could sometimes be confusing. Why? Because actually the vessel was somewhere on the PL, so vessel's movement has been from the PL only. But we had to include this so that we could get the coordinates of point Z. So now having got point Z.
Okay, beta. So we have obtained the position Z now. Once position Z is obtained, we are ready to go into the plotting part. We can now plot both the PLs and find our fix. Up to here, any doubts, beta?
Sir, in the tabular form, delight and departure values we will get by plain sailing.
Yeah, that's correct, beta. You apply the plain sailing formulas. Dlat is equal to distance cos course, departure is equal to distance sine course, and that's how you get the values.
All right, sir.
Sir, in this question, the distance from DR to ITP, is that possible, sir? We can omit that DR to ITP and we will run only the steaming and current will get one position. From there, we can draw DR to ITP with the graph and find out the position.
Beta, you can do that, but what is the advantage of doing that? See, calculation has to be done. Even if you omit the DR2X leg, calculation you will still have to do, but your plotting will increase, right? So if you are doing calculation, why not include that in the calculation itself?
Okay, sir, all at one go. Take
Okay.
his box.
Practically, fundamentally speaking, can be done. Basically, what you are saying is that I will transfer the DR and then I will plot the intercept graphically to get the transferred PL. That's perfectly all right. You can do it
Correct.
fundamentally. Yeah, that can be done.
Okay, sir.
Okay.
PL only, but we had to include this so that we could get the coordinates of point Z. So now having got point Z through which to transfer the PL, it's lat long. We also know the direction of the transferred PL. It shall be perpendicular to the azimuth in the morning. That shall be 171 degrees to 351 degrees true. We know that the second observation has been latitude by meridian altitude. So observed lat is 18 degrees 40 minutes south. Direction of the second PL is east-west. D lat from Z to observed lat is 6.5 minutes south. So you can see it's 6.5 minutes south. Now having got this, now it's a case of simultaneous observations. Only thing is one is a transferred PL, other is an observed PL. So we get going with the plot. We have on the screen latitude of Z coming up here. We have the longitude of Z coming up here. So obviously point Z is here at the intersection of the two. So that is point Z. It's through point Z that the transferred PL has to be drawn. We are all conversant with this part. So there comes the transferred PL with two arrows at each end. Now we choose on a suitable scale.
Okay. So beta, the transferred PL is there in the plot. Any doubts up to here? Very good, beta. Great.
1 centimeter is equal to 1 mile. Why? Because the D lat is only 6.5 minutes south. So we can just mark that off and mark the observed lat. So here comes the observed lat. That is the lat at the time of second observation. The second PL shall coincide with the observed lat being east-west. So here comes the second PL. PL at the time of Marpas. So now this transferred PL and the second PL are for the same time. So this is the position of the vessel at the time of second observation. And now we know that the latitude is directly visible on the screen.
Okay, so we have the second PL also as well as the fix in the plot now. Any doubts up to here?
No, sir.
Great, beta. Very good.
We can read off the departure on the screen from the graph, which is 1 minute east from longitude of Z. Departure is converted into D long. You can see all this working coming on the screen. And then that D long is applied to the longitude of Z, and that gives us the fixed long. And eventually we get the coordinates of this fix as 18 degrees 40 minutes south, 178 degrees 53.9 minutes west. Please see here, this longitude of 1.8 minutes east applied to longitude of Z gives us this longitude of fix, and therefore through deployment of our knowledge of simultaneous observations, we can get this plot done and get our answer. We take one more question.
So here we have our fix now in the plot. So have a good look, beta. Let me know any doubts coming in. Clear, beta? Understood? चलें आगे?
Yes, sir.
Okay, good.
Deployment of our knowledge of simultaneous observations, we can get this plot done and get our answer. We take one more question. At 0830 hours in DR 48 degrees 30 minutes north, 024 degrees 20 minutes west, an observation of sun gave an intercept of 4 minutes towards an azimuth of 100 degrees true. Ship course and speed were 250 degrees true at 14 knots. Later at 11:30 hours, having run up DR for calculation, please pay attention to the phrase, having run up DR for calculation, a second observation of the sun on azimuth of 175 degrees true gave an intercept of 3 minutes away. Required ship's position both at 11:30 hours as well as at noon. Now, first we'll draw a rough diagram to figure out what is to be transferred, and then mathematically calculate the transferred position. So let's first draw the DR at 8:30 hours. We draw the first PL. So this is the azimuth. We mark off the intercept towards the azimuth. That becomes the ITP. We draw the first PL here. So we get the first PL, which is perpendicular to this azimuth. So direction of the PL is 010 degrees to 190 degrees true. Now, before you apply run, please go back to the question. It says second observation, that is 11:30 observation, which is also an intercept observation, has been solved by using a DR, 11:30 DR, which was obtained by running up the earlier DR, that means 8:30 DR. So that means in this case, if I run up the ITP, yes, I can transfer the first PL, but then unless I have the 11:30 DR, I'll not be able to plot the second PL. So in this question, what makes better sense is that we transfer the 8:30 DR, and through the transferred DR, with respect to transferred DR, that 11:30 DR, we plot the first PL transferred and also the second PL out there. So please pay attention to the question. If the question said that the second observation has been solved by using the position obtained by running up the ITP, then we would have applied the run on the ITP and run up the ITP. But in this case, it says it has been obtained by running up the DR. So what do? We run up the DR. We apply the CTS for 3 hours. The distance becomes 42 miles. We apply, and this position is the DR at 11:30. Now, with respect to this DR at 11:30, we can plot the first PL transfer with same azimuth, intercept, and direction of the PL. So we get the first PL transferred here. We can draw the second PL with respect to this DR, azimuth 175, intercept away, and we have perpendicular to the azimuth. This is the second PL. Obviously, this point becomes the fix at 11:30.
Beta, any doubts coming up to here? Did you understand?
सर इसमें डीआरए ही क्यों किया गया था? डीआरए लाइट डीआर लाउड के साथ ट्रांसफर किया गया।
ओके बेटा, अगर डीआर ट्रांसफर नहीं करते तो फिर क्या ट्रांसफर करना पड़ता हमें? Beta, if we did not transfer the DR, then what will we need to
ITP.
transfer in that case?
ITP.
ITP. Now tell me, if we transfer the ITP, I agree that you can transfer the first PL, okay? You will exactly reach at the ITP of the transferred PL. You can draw the transferred PL. But how will we draw the second PL, second observation? Because second observation is plotted with reference to transferred DR. So we will not get the transferred DR in that case, na?
Yes, sir. Yes, sir.
Clear? Clear, beta?
Yes, sir. Yes, sir. Yes, sir.
Okay. So you need to be very careful about the wording which is given in the question.
Yeah. Yes, yes. DR position
Right.
प्लॉट में सर पहला हम लोग 11:30 कैलकुलेशन करके 11:30 वाला पहले बताएंगे ना सर, तो उसके बाद सेकंड वहीं से लेंगे।
Yeah, that's
Pehla-
correct, beta. We will calculate the 11:30 DR and then we are going to plot both the PLs.
And now this fix, what we got here is 11:30 fix, correct, sir?
Yes, that's 11:30 fix, beta. Okay.
That means in this case, mathematically, what should we be interested in? We should be interested in finding the latitude and longitude of 11:30 DR. So we can apply plane and parallel sailing. Obviously, this diagram was not to scale. So we have this column out here. We have only one leg out here. That is the ship's own steaming. We get the DLAT as 14.4 minutes south and departure as 39.5 minutes west. We apply this DLAT to the latitude of 8:30 DR and we get latitude of 11:30 DR as 48 degrees 15.6 minutes north. Then we find the MLAT between 8:30 latitude and 11:30 latitude. We use this latitude to convert this departure of 39.5 minutes into D long. Apply this D long to the longitude of 8:30 DR, and once we apply this to 8:30 DR, we can get the longitude of 11:30, and this gives us the position of 11:30 DR, which can be used, as you can see in this rough diagram, to plot both the 11:30 PLs, one transferred PL, other observed PL.
So 11:30 DR is now calculated, beta. Any doubts still here? Very good.
Now, having got the 11:30 DR coordinates, the two PLs can be plotted. We know the transferred PL shall have a direction of 010 degrees to 190 degrees true, and its ITP shall be This is this azimuth and intercept out here. And likewise 1130 PL. We'll get the ITP using azimuth of 175 degrees true, intercept 3 miles away, and direction of the PL shall be perpendicular to azimuth, which comes to 085 degrees to 265 degrees true. So we can get going with the plot. You can see on your screens the DR position being identified. This is the latitude of DR, this is the longitude of DR. So let's first plot the transferred PL. We take a scale of 1 centimeter representing 1 mile. This is the azimuth of the transferred PL. We mark off this intercept, which is 4 miles towards. This becomes the ITP. And to the ITP, we draw the transferred PL represented by 2 arrows at each end.
So transferred PL is plotted now, beta. Any doubts up to here? Very good.
Then we mark off azimuth for the 1130 PL 175. This is the 175 azimuth. And we have the intercept in the away direction, 3 miles. We mark off the intercept here. This is the ITP then. We draw the second PL marked with single arrows. Why? Because that's a celestial PL, observed PL, and not a transferred PL. Therefore, this becomes the fix at 1130. Now we can measure its DLAT from DR lat. We can measure the departure from DR long, convert the departure into D long, and apply it to the longitude of the DR, and we can get the coordinates. You can see DLAT is measured off using this scale, comes to 3.4 minutes north. So is the departure, which comes to 4.7 minutes east. And then from the plot, we can apply these and get the position at 1130. 1130 fixed latitude then comes to 48 degrees 19 minutes north. Departure can be converted to D long, applied to the longitude of 1130 DR, and that gives us the longitude of the fix as 25 degrees 12.4 minutes west.
So we have obtained the 1130 fix here, beta. Any doubts up to here?
No, sir.
Great, beta. Very good.
So this way we are able to get the coordinates of the vessel's position at 1130 hours. Now from 1130 fix, we can get the noon fix by applying the run for half an hour. And we can mathematically do it. We have the 1130 fix whose coordinates we have just calculated. Now for half an hour, we apply the run. The vessel's course is 250 degrees true. In half an hour, the distance shall be 7 miles. We get the corresponding DLAT and departure. This DLAT can be applied to the latitude of 1130 fix, and that will give us the noon lat. Using the MLAT between 1130 lat and 1200 lat, we can convert this departure into D long, apply that D long to the longitude of 1130 fix, and that gives us the noon longitude as 025 degrees 22.3 minutes west, and hence we get the coordinates of the vessel's position at noon on that particular day. And that's how this question can be completed. Just to summarize and to draw your attention, please be careful on taking a call as to which point needs to be transferred.
Clear, beta. Any doubts in the solution?
Excuse me, sir.
Go ahead, beta.
Sir, during first DR, sir, from which position we are going to start? DR position or, sir, where PL will be intersected, sir? It means we will start from PL or we will start from the DR, sir, position? I just want to see the slide.
Okay. I'll take you back. This is the rough diagram, beta.
Okay, so 8:30 start from DR position that run start
Yes.
from. Okay.
That's right. That's right.
Okay, sir.
Clear, beta? Clear?
Yes, sir.
Okay. All
Sir,
right.
if we have this current in this question,
Right.
we will apply allow the current at the end of the 42 miles, and then we'll transfer this first PL, right, sir?
That's correct, beta.
And when you are calculating the known position, we will again make one triangle, and then we'll allow the current for half an hour, and then find out the next position, sir.
Yeah, that's correct, beta. So you will have two legs in the day's work calculation here. One will be the course and distance leg, another will be the current leg. And same thing will apply when you are finding the known fix.
Okay, sir. Okay, sir. Thank you.
Okay, good. So you see, beta, a small change in the wording leads to the method getting different. So it is very, very important that we read these questions very well to understand what is needed to be done to solve the question. Great. So let's move on to the next example.
Sir, like this wording, having run up the DR position, do we have any other wording like this? Because initially when we say having run up DR, I really didn't understand what does it mean, sir. After only seeing this rough diagram, I can make out running DR is from the DR position. Do you have any other wording like this?
Okay, I'll show you, beta. I'll show you. Give me a minute. Now, let us, to make the concept clear in your mind, let us change the question slightly. Instead of DR, I'm going to cut the DR. Let us say the question was mentioned here as ITP. Right? That's the only other option which is possible. So the question is saying, having run up ITP position for calculation, a second observation was taken. Right, beta? Understood?
Yes, sir.
Now, if this was the question, what will we do? Then we are not going to transfer the DR. What we are going to do is, we are going to transfer the ITP. So I will apply a run to the ITP, and it will take me exactly to this position, because it is going to make a exact parallelogram. So it is going to take me to this position. Let's give it a name. Let's call it X.
So same like how we did in the previous question, correct, sir?
Yes, that's correct. That's correct. Now, when you apply the run on the ITP, the first PL will be transferred as usual. So you will get the first PL exactly as it is now. There will be no change in the first PL. The change will come in the second PL, because the second PL azimuth and intercept will now be plotted from the ITP like this. And your second PL is going to be somewhere here. And the fix is going to change. This will be the fix then. So this is the other possibility which can come in the questions, beta. Getting clear?
Okay, sir.
Okay, good, beta. Good, very good. Okay, all right. So let's see another concept now with a new question.
Noon longitude as 025 degrees 22.3 minutes west, and hence we get the coordinates of the vessel's position at noon on that particular day. And that's how this question can be completed. Just to summarize and to draw your attention, please be careful on taking a call as to which point needs to be transferred. Now we have a question which involves transfer of position circle. At 11:03 hours, an observer on a vessel steering 336 degrees true at 14 knots found the sun altitude to be 89 degrees 29.2 minutes, bearing southeasterly. Declination of the sun is given, GHA of the sun is given. Later, at 13:12 hours, a point of land whose position is given in the question was detected by radar at a range of 23 miles. Find the vessel's position at the time of second observation. Now, before we start with the question, I'm sure all of us would agree from our knowledge that at 11:03, it's a high altitude celestial observation. So we get a position circle with GP of the sun as the center and TZD as the radius.
Is that clear up to here, beta? Very good.
At 13:12, we again get another position circle with the point of land as the center and radar range as the radius. Now, since we have two position circles separated by a certain interval, we need to run up the first position circle, and to do so, we'll have to transfer nothing else but only the center of the first circle. We do not have a choice when it comes to transferring position circles. It is the center and only the center that needs to be transferred. So we have the 1103 PC. That 1103 PC shall be drawn with the center as the sun's GP. What will be the GP of the sun? Latitude shall be equal to the declination and longitude shall depend on GHA. Here the GHA is more than 180. So the longitude will be, because longitude cannot be more than 180, it shall be 360 minus GHA, and this time the longitude shall be easterly. So we get the coordinates of the GP, and that becomes the center of 1103 PC. Radius of 1103 PC shall be equal to TZD. True altitude is given as 89 degrees 29.2 minutes, which gives us the TZD or the radius as 30.8 miles. Now we run up this center. Which center? Whose latitude is 13 degrees 26 minutes south and longitude is 055 degrees 08.8 minutes east. We run it up from 1103 to 1312. During this interval, the vessel shall be doing a course of 336 degrees true, and at 14 knots, the vessel shall be covering a distance of 30.1 miles. Now, this part of it I have not shown on the screen, but I have calculated it. You can also calculate just to save on time. I'm assuming that you'll be able to calculate the coordinates of the transferred center, 1103 center, which is transferred, applying this run using plane and parallel sailing. We get the 1103 PC transferred to 1312, center of that rather. The center comes to 12 degrees 58.8 minutes south and 054 degrees 56.4 minutes east. Please do this calculation and see that you're comfortable and you are able to get this as the center of the transferred PC.
Right, beta. So is it clear up to here? Any doubts?
Sir, excuse me, sir.
Go ahead, beta.
Sir, the radius is whatever 30.8 is calculated, sir. सर
Right.
इसका थोड़ा एक्सप्लेनेशन मिल पाएगा सर कि ये कैसे लिया अपन ने TZD का?
बेटा मुझे एक बात बताओ. Yesterday I showed you a slide where we saw how a high altitude observation is plotted. तो उसमें मैंने
Yes,
आपको
sir.
बताया था कि सर्कल का सेंटर क्या होगा और रेडियस क्या होगा. You remember?
Yes, sir, बताया था सर.
So what was the radius? Have a look बेटा. नोट किया था कल?
सर रिकॉर्ड है सर, बट थोड़ा सा मतलब I cannot recall, sir.
इसीलिए डाउट आ रहा है बेटा. The radius of the circle is the true zenith distance, the TZD.
Okay,
So
sir.
that's why we have taken the radius as TZD, which is 30.8 miles. TZD is 90 minus true altitude.
Okay, yes, sir.
Okay, beta, clear?
Yes, yes, sir. Thank you, sir.
Okay.
So can you explain again one more time how we get this center position?
You mean to say in a high altitude observation, how do you get the center and the radius?
No, sir. Below then this transferred PC position center.
Okay. Beta, this high altitude observation was taken earlier, 1103, right?
Yes, sir. Yes,
Now the second observation is taken at 1312.
yes, sir.
So we will need to transfer this position circle from 1103 to 1312, right?
Yes, sir.
Now to transfer a position circle, we have to transfer its center. The run is applied on the center of the circle. So we have the center of the circle as 1326 south, 0558.8 east. We apply the run, which is 336 and a distance of 30.1 miles. This is the distance. So when you apply this course and distance to this center, you get the transferred center, and that is what is calculated.
Okay, sir. Okay, sir.
Now we can plot this transferred center, and if we draw a circle with a radius of 30.8 miles, it will be our transferred PC.
Okay, sir.
Okay.
The radius obviously shall remain the same as the original PC, which will be 30.8 minutes. Now 1312 PC, which is by radar range, will have its center as the point on land, whose lat and long is given in the question, and the radius shall be 23 miles. Now, having transferred the center of the first PC, now we can draw two position circles for the same time. One position circle shall be the transferred position circle. The first position circle transferred to 1312 with the center in 12 degrees 58.8 minutes south, 054 degrees 56.4 minutes east, and radius of 30.8 minutes or miles. The second position circle will be observed position circle for 1312 with center as the point on land and radius as the radar range of 23 miles.
So we have two position circles now. Both the circle center is obtained, the radius is also obtained. Now the only thing to do is plot these two centers, make these two circles, and the intersection point will give us the fix.
So excuse me, sir.
Go ahead, Beta.
For this transferred PC, the center is calculated by this day's work type, sir.
Yeah, that's correct, Beta. Plain sailing, day's work.
Okay, sir.
Okay.
So we have the 1312 transferred PC, whose center we are calling as X, whose coordinates are 12 degrees 58.8 minutes south and 54 degrees 56.4 minutes east, and the radius of the PC shall be 30.8 miles or minutes. And 1312 PC, which is an observed position circle, we are calling it center as Y. Coordinates of Y and radius of the PC are there on the screen. Now the DLAT from X to Y, X is the center of transferred PC, Y is the center of the observed PC. DLAT between their centers happens to be 40.8 minutes north. That means Y is 40.8 minutes north of X. And D long between the two happens to be 11.4 minutes west, and MLAT between the two is 12 degrees 38.4 minutes south. Using this MLAT, this D long can be converted into departure from X to Y, and the departure comes to 11.1 minute west. Now with this information, we can get going with the plotting. First, we have this latitude of X, that is the center of the transferred position circle. We have the longitude of X. Obviously, this point is the point X. And what is point X? It is the center of the transferred PC.
Up to here, any doubts, Beta?
No, sir.
Yes, sir. This dlat x and d long, that this whatever written in the pink, sir. Can you explain this one, sir?
Okay, beta. Now you see, beta, we have two circles to be plotted. One is the transferred BC, whose center is at 1258.8 south. Another is a observation taken at 1312. Its center is at 12 degree 18 minutes south. So we have taken the difference of latitude between these two, 1258.8 and 1218. That comes to 40.8.
Okay, sir.
Okay. Similarly, we have the longitudes 54, 56.4 and 54, 45. The D long between them is 11.4.
Okay, got it, sir. Got it.
Okay, got it, beta? Then we converted the D long into departure, okay, using the D long departure formula, and that comes to again 11.1 minutes departure.
Yes, sir. Got it.
Okay.
Now, using a suitable scale we have taken is 1 centimeter representing 5 miles, because distances involved are slightly larger, like 23 miles and 30 miles, and therefore the scale is 1 centimeter is to 5 miles. Using this scale, we can mark off the D-lat and get the latitude of the point Y. So we mark off this D-lat using this scale. The D-lat you can see here, the D-lat was 40.8 minutes north. We mark off the D-lat and we get this is the latitude of point Y. Likewise, we can mark off the departure from X to Y and get the longitude of point Y, and obviously then where it intersects here is the point Y, and this point Y is going to be the center of the position circle, which is by radar range.
Any doubts up to here, beta? Good.
So what we have done, we have plotted point X and Y. Now with point X as center and radius of 30.8 miles, using the scale of 1 centimeter equal to 5 miles, we draw the transferred position circle, and this one is the transferred position circle which has come on the screen. Likewise, with Y as center and radius of 23 miles using the same scale, we draw the 1312 observed position circle. This is the 1312 position circle, and this is the 1312 transferred position circle.
Both the position circles are on the plot now, transferred PC as well as observed PC. So any doubts up to here?
So this radius also we have divided by 5, sir, to the scale.
Yeah, that's right, beta.
तो पोजीशन कौन सी वाली होगी इसमें? दो जगह इंटरसेक्ट हुए हैं, ये साउथ ईस्टर्ली बेयरिंग से पता लगेगा कौन सी वाली पोजीशन है.
Exactly, that's right. That's right.
Intersecting at this point here, which we can call as A, and it's also intersecting at this point, which we can call as B. That means in this case, the vessel could be either at position A or position B. Now, if you go back to the question, it says the sun was bearing southeasterly. Now, obviously, the sun's position in this case will be represented by its GP, which is getting transferred to X. So obviously, if the sun was south bearing southeasterly, the vessel has to be at point A for the sun to bear southeasterly. Therefore, in this case, position B gets ruled out, and the vessel's position happens to be then point A. Now we can measure its D-lat from one of the reference latitudes, also the departure using the same scale as the scale for the plot. We get the D-lat from latitude of X as 21 minutes north, and we get departure from longitude of Y as 13.3 minutes west. We can use plane and parallel sailing formula and use the coordinates of the reference points from where the measurement of DLAT and departure has been done, and we can then apply them here, and we end up getting, when we convert the departure into D long and we apply, you can see the working on the screen, and it eventually gives us the fix at 1312 as 12 degrees 37.8 minutes south and 54 degrees 31.4 minutes east. So
Right, beta. So the position is obtained. Have a good look, beta. Let me know any doubts.
Sir, why the B position is ruled out, sir?
Okay, beta, the question says that the sun was bearing southeasterly. So in this plot, the sun is represented by its geographical position, which is at x. So if you take position B, that means the sun is southwest of you. X point is southwest of B. That's why it is ruled out.
Okay.
So finally, this departure which we have calculated, why it is taken from Y, sir? It should be from X, right?
You can take the departure from any reference longitude of your choice. Recommended is the nearest longitude.
Okay, sir. And as well as this DLAT also, it is taken from X now. So
Yes, you can take it from Y also. There is no issue at all. You can take it from Y also. You should get the same answer.
Okay, sir.
कैन यू शो से पहले वाला जो कैलकुलेशन किया था ग्राफ से पहले वाला?
Okay, beta. Okay, I'll take it back. Here it is, beta.
Yes, sir. Okay, sir. Thank you.
Okay. Okay, beta. Great. Very good, beta. So these were the staggered plotting questions. So I hope that you are gaining confidence in staggered plots now. I'm closing the screen.
So this cocked hat and index error, we will also do.
Oh, that I'll show you. उसके लिए I'll have to show you through presentation. That method it has got a lot of steps. So I'll show you that, beta. I'll show you that now. So that is the only thing remaining.
Yes, sir.
Okay, great. So these questions are done.
So for staggered, same like GC, you gave a set of questions with solutions. Same like that, you have a set of questions with solution in the staggered, so that we can practice more. I think your practice is quite more much for this.
I'll give you, beta. I'll give you.
Okay.
Okay, all right. So, beta, let's take a short 5 minutes break and then we start with cocked hat. Okay?
Okay, sir.